Hi, everyone. We are going to start our very last unit of the year today, which is crazy to think about, but this is it. So our last unit is another geometry unit, and in this unit, we're going to talk about area, surface area, and volume. So we did a little bit with area in the last unit when we talked about area of circles, but we're going to talk about the area of all two-dimensional shapes today. Okay, so I guess the first thing we should talk about is what exactly is area? Area is really defined as the amount of space inside a two-dimensional shape. So why don't we write that and then I'll explain it a little bit more. Okay, so the amount of space inside a two-dimensional shape. So a couple things to talk about. What's a two-dimensional shape? A two-dimensional shape just means that it's flat. So it doesn't have any height to it. And so when you think of area, think about you're trying to cover something. So if you're trying to cover a floor, for example, you might be thinking of area because you're going to put carpet down. Okay, so the floor is a two-dimensional shape. It doesn't have any height. You're just covering it. And so maybe we could put that as an example here. Carpeting a room. Kind of similarly, if you are thinking about like putting hardwood floors down or tiling down or any kind of flooring, that's all considered area because you're going to cover the floor. Another thing you could think of area like is if you have a pool and you are trying to, cover your pool. So let's say you wanted to buy a pool cover. That's another great example of area because it's a flat surface that you're covering. So I'm going to put that here, covering a pool. Another thing you might try and cover is maybe if you were planting grass seed on the lawn, you would be talking about area because you're covering the lawn in seed. Okay, so that's the biggest thing to know is that it's covering a two-dimensional shape. So it doesn't have any height to it. All right, so facts and characteristics. First fact is that we use square units. Okay, so anytime you're talking about area or covering, you're going to hear feet squared or meters squared or inches squared. Okay, so in fact, if you go to buy carpet, you would have to tell the person that you're buying this from how many square feet of carpet you need. Okay, we actually just put some new flooring down in our sun porch, and I had to figure out what was the area of my floor in there so that I would buy enough flooring to cover the whole porch. So this is definitely something that will be applicable to you at some point in your life, especially when you own your own home, because you're going to be doing a lot of things like that, getting carpet and flooring and whatnot. Okay, so it's always square units. That's, I'll put here feet squared, inches squared, etc. Okay, so another fact or characteristic we talked about is that it's for two-dimensional shapes. Okay, so we can't find area of, let's say, a box. Okay, we can't find area of the the couch. Okay, those are all three-dimensional objects. So this is, like I said, flat, 2 dimensions. And the last thing we'll write here is it's used when trying to cover something. So you might be thinking, well, wait a minute, what if I wanted to cover the couch? What if I wanted to buy a couch cover? That is actually called surface area. Okay, so surface area, and we'll get to this later in the unit, is when you're trying to cover a three-dimensional object. So it's possible, it's just not regular area. Okay, so along those lines are some non-examples. So why don't we say a couch cover, since we just talked about that. Okay, that's a three-dimensional object that we're trying to cover. Kind of similar, I mentioned a box. So maybe if you're wrapping a gift, so even though we're trying to cover that gift, it's not flat. It's a three-dimensional box. And so that is considered surface area, not regular area. We could say painting a room. So even though your walls are flat, oops, I didn't mean to write wall. Painting a room. Even though your walls are flat, we consider that to be surface area because we are looking at an entire room. Now, if you were just painting a wall, that would be area because that's a flat surface, absolutely. But if you're painting a whole room, we would consider that surface area. And the last thing I was thinking of is going back to the pool example. So we said a pool cover is area, but filling a pool, that's not area. That's actually volume, which again we'll do later in the unit. Okay. All right, so down here I wrote, how do we label area? And we've already talked about how we label area in square units. And I want to show you why that is. So if I were to say, okay, here's my porch. So my porch is kind of like this. This is the door here, so I didn't tile in front of the door. So if I was trying to figure out how many square feet, okay, that was what I needed to figure out. How many square feet of flooring do I need to cover my porch floor? What I'm really doing is I'm figuring out how many, so this is what I'm really looking at here. How many square feet do I need, this is not a great picture, to cover the floor? So I want you to picture that these squares that I drew were actually squares, okay, and they don't look perfect by any means. But each little square here would represent 1 foot by 1 foot, okay? So this is 1 foot, this is 1 foot, and I'm telling you that it's a square because I'm showing you all the sides are the same. So when you say square feet, it's how many little 1 by 1 foot squares would I need to cover the floor. So that's why we call it square units, okay? Because it's literally squares of whatever unit you're measuring with. If I was measuring in square inches, I would have little inch squares that would be covering the floor. Okay, so it makes sense to use feet because the floor is big. Inches would be if I was covering like a little dollhouse floor or something. Okay, so how is area different from surface area? So I kind of mentioned this before. So area is for two-dimensional shapes, so flat objects. Where surface area is for three-dimensional shapes. So three-dimensional shapes just means it has height to it. Okay. How is area different from volume? So volume fills. I want you to think of that keyword. Volume fills where area covers. That's the difference. Okay, filling versus covering. Okay, so hopefully you have a good understanding of what area is, because now we're going to look at how to find the area of a bunch of different shapes, 5 of them to be exact. And some of these you've seen before. I know you've done these. My daughter is in 3rd grade, and she has done the area of the first 2 shapes. And so I know you've seen these over the years. The new ones might just be the parallelogram, the triangle, and the trapezoid. Okay, so These formulas, again, you might be very familiar with already, but we're going to write them out here. So the area of a rectangle is equal to length times width. Okay, and I show you the length and the width there. The area of a square, you can also use length times width for if you want, but because squares have all equal sides, if I were to think of it as side times side, that's the same as side squared. So you're actually going to see me use that whenever that shape is there, whenever we have a square. Okay, but you could use either one. For a parallelogram, we use base times height. Okay, so the base times the height there in the picture. For a triangle, there's two different formulas you may have seen. The first one is 1/2 base times height, or some people write it as area equals base times height divided by 2. So remember, if you multiply something by 1/2, it's the same as dividing by 2. That's why you can use either one of those formulas. And the reason I have two different pictures of triangles here is because one of them, the height, is shown kind of in the middle of the triangle. So anytime you see a right angle, that shows you where the height is. And then in the other one, the height is actually a side because the sides make a right angle. So we'll talk about that too when we see our examples. So the trickiest one, I think, is the area formula for a trapezoid. So this one is 1/2 of the height, so 1/2 times height, times, now this has to go in parentheses, the length of the first base plus the length of the second base. So that little B1, B2, those are called subscripts, and it just means that you take the first base and you add it to the second base, and then it gets multiplied by half the height. Okay, so we'll talk about that formula when we do some examples. All right, so we're going to start off with a rectangle here. So when you are finding the area, it's important that you follow the 3 steps of write your formula, substitute in your values, and then give an answer. So each problem should have at minimum 3 steps of work. Okay, so because we know this is a rectangle, I'm starting with my formula, area equals length times width. Now, it doesn't matter in this case which side you call the length and which side you call the width, because we're just multiplying the two numbers together anyways, and the commutative property says you can multiply numbers in any order and you'll get the same answer. Okay, but I tend to say that the longer side is the length, so I'm just going to put that first. So I'm going to multiply 14.1 times 0.3. Okay, and you can absolutely use your calculator for this. You do not have to do this by hand. So if you multiply those two things together, you should get 4.23. And then remember, we label it with meters squared because I wanted to see how many square meters make up that rectangle. Okay, number 2. This is a square. I know that because it shows me that all the sides are the same length and I have a right angle there. So I'm going to use the formula area equals side squared. And you could use length times width like I mentioned before. It will work the same way. So since each side is 4/7 of an inch, I need to do 4/7 squared. Okay, so if you remember to square a fraction, or square any number, it means to multiply it by itself. So I'm really doing 4/7 times 4/7, which gives me 16/49. And this would be, again, inches squared. Okay, so that one you could have put in your calculator. You could have done using the ABC key, but I think it's pretty easy to do that one by hand because you're just multiplying straight across. All right, number 3, we have a rectangle here. So we're going to go back and use our length times width formula. All right, so the length I'm going to call 3 3/4 just because it's the longer side. But again, it doesn't matter if you were to reverse these, we would all get the same answer. All right, so in order to multiply fractions, I need to change them both into improper fractions. So 3 and 3/4, to do that, I do 4 times 3 is 12, plus 3 is 15. So I'm going to write my work up here, and I keep the denominator. So that becomes 15/4. And then 1 and 2/3 would be 3 times 1, which is 3, plus 2, which is 5 over 3. And then we can cross cancel here. The 3 and the 15, if I divide them both by 3, I'm going to get 1 and 5. And when I multiply straight across, I get 25 over 4. Okay, which I should make back into a mixed number. So 4 goes into 25 6 times, because 6 times 4 is 24, and that leaves 1 left over out of 4. And we'll label that centimeters squared. Okay, and again, if you were to use your calculator and you were using the ABC button, you would have gotten the same thing. All right, number 4, we have another square. So area equals side squared. Each side is 1.2, so this is really 1.2 squared. And remember, squaring something means to multiply it by itself. So 1.2 times 1.2. Now, I know 12 times 12 is 144. So if I use that knowledge and I say, okay, there's 2 decimal places, which means I would move 2 decimal places back, I'd get 1.44. And this would be yards squared. Okay, so there's your rectangles and your squares, which again, I think you are familiar with already from maybe 6th grade. But now let's talk about some other shapes. So number 5, you have to know this is a parallelogram. Remember, parallelograms are quadrilaterals that have opposite sides being parallel and opposite sides that are equal. So that's from our last unit, so hopefully you remember that. And the area formula is base times height. So the base of your parallelogram is kind of like what it sits on. And the height is where you see that right angle. So a really easy way to pick out the base and height is to look for that right angle in the 2 sides. So this side here, and in this case it's not a side, it's just showing you the height. That shows you the base and height. Okay, because sometimes you'll have extra numbers in the picture, so you just want to make sure you know what numbers you're supposed to use. So 3 1/3 times 2 2/5. All right, so I'm going to make these both into improper fractions again. So 3 times 3 is 9, plus 1 is 10/3, times 5 times 2 is 10, plus 2 is 12/5. And we can do some cross canceling here. So 3 and 12 I can divide by 3. 5 and 10 I can divide by 5. And so that gives me 8 inches squared. All right, moving on to number 6, we have a triangle. So again, for triangle, we can either use 1/2 base times height or base times height divided by 2. Totally up to you. For this one, I'll use 1/2 base times height, and then if there's another one, I'll switch it up. Okay, so this is what I was talking about where they give you extra numbers that you don't need. So for the triangle, we need the base and we need the height. Okay, so the way we figure this out is we look for the right angle. What makes the right angle? The base, so the base is going to be 5, and the height. That's what makes the right angle. So this 13 yards we see over here is just a side of the triangle, okay, which we don't need to find the area. So you have to remember it's where that right angle is. It's the 2 parts that make that right angle. That's the base and the height. So we're going to have 1/2 times the base, which is 5, times 11, which is the height. Okay, so what I would do is I would say, let's do 5 times 11, which is 55, and then 55 times 1/2 is the same as 55 divided by 2. So that gives me 27.5 yards squared. Again, because you're multiplying all three of those things together, you could have done 1/2 times 5, which is 2.5, and then 2.5 times 11 gives you 27.5. So there's lots of ways that you can multiply those numbers together and you'll still get the same answer. All right, so number 7 is another triangle. It looks a little different. And again, because our formula is using the base and height, I'm going to use the other one for this, base times height divided by 2. We look for the right angle. Okay, so here's the right angle. And the two sides that make that right angle, that's the base and the height. So this 22.7, we don't need. That's just another side of the triangle that is not part of the area. Okay, so again, look for the right angle, and that is your base and height. So I'm going to say 15 times 17 divided by 2. Okay, or you could still be doing 1/2 times 15 times 17. Both will give you the same answer. Okay, so if I do 15 times 17 equals, and then divide by 2, I'm going to get 127.5 meters squared. Okay. All right, our last shape that we haven't done yet is the trapezoid. So remember, to spot a trapezoid, you are looking for a quadrilateral that only has one pair of parallel sides. Okay, so the other two sides are not parallel. They're going to intersect at some point if you were to continue them on. So number 8 is a trapezoid for sure. Let's get our formula down. So this is the longest one. Okay, so a couple things. First of all, to find the height of your trapezoid, again, look for the right angle. Here's the right angle, which means this is the height. That's how tall the trapezoid is. So when we start plugging our numbers in, that's how I'd figure out what the height is. Okay, the bases, these are a little bit easier to spot. The bases are the two sides that are parallel. Okay, so this side of 14 and this side of 10, those are the two bases because those are the sides that are parallel. So I'm just going to put them in as base 1 and base 2. Again, it doesn't matter the order. I could have done 14 plus 10 and just adding them, so the order doesn't matter. Okay, so this is the part that's important. Because I have different operations here, meaning I have multiplication and I have adding, I have to follow my order of operations. Okay, so PEMDAS, which means I need to do what's in the parentheses first. So if I go through and I add, I'm just going to bring the rest of my work down. 10 plus 14 is 24. Okay, so after you've done the adding, now all we have is multiplication. So I can go ahead and I can do that in any order. I can do 1/2 times 5 is 2.5, and 2.5 times 24 is my answer. If I'm trying to do this in my head, I like to take half of the even number. So half of 24 is 12, and then 12 times 5 is 60. So really you can do any order you want, but you should get 60 meters squared. All right, so 2 more trapezoids here. Number 9, let's write out our formula. 1/2 times the height times base 1 plus base 2. Okay, so let's pick out the height first. Look for that right angle. Here it is. So the height is right there. It's how tall your trapezoid is. So we're going to plug in 3 for the height. And then my bases are the sides that are parallel. So I see one base is 11 and one base is 15. So that 2 that you see is not used. That is not needed for our area formula. All right, so following order of operations, I'm going to do what's in the parentheses first. 11 plus 15 is 26. and then I can go through and I can multiply 1/2 times 3 times 26. And again, if I was doing this in my head, I would say, okay, 1/2 of 26 is 13, and 13 times 3 is 39 meters squared. Okay, last one. Another trapezoid. Get your formula here. So this trapezoid is on its side, okay? So when you're looking for the height, it's really not how tall it is, but you can see right here, there's your right angle. It's this distance. So if I were to turn that trapezoid and, put it the right side up, you would see that 2 is still your height. So we're going to have 1/2 times 2. Now your bases are still the sides that are parallel. So 1.5 is one base, and 2.5 is the other base. Okay, now I'm going to do order of operations. I'm going to add what's in the parentheses first, which gives me 4. And then I'm ready to multiply. So 1/2 times 2 is 1, and 1 times 4 is 4. So 4 meters squared is the area. All right, great job.